Alright, this is the first word problem example in section 4.4. So the key with these word problems is to remember to think about what the equation and what you're solving for actually means physically. You'll see that here a couple of times in this example. So we have a rocket is launched into the air, and its motion is modeled by this equation. So I'm just going to sketch briefly. It's something like this, right? Where, so we have height, h of t is the height in meters above the ground, and t is in seconds, time in seconds. So determine when the rocket first reaches a height of 80 meters. So what you would do here is say, okay, at 80 meters, h of t equals 80. So we'll set our equation to be 80 is equal to minus 5t squared plus 37t plus 20. And we want that equal to 0. I'm actually going to bring everything here over to the left-hand side to get rid of this negative in my t squared term. So that'll give me positive 5t squared minus 37t, and then 80 minus 20 is positive 60 equals 0. Okay, now we're good to go ahead and use our quadratic formula to solve for when time, at what values of time will h of t actually equal 80. So t is equal to negative b plus or minus the square root of b squared. Whoops. So b squared minus 4ac. There's my square root. And this is all over 2a. So when you work out under the root here, you get square root of 1369 minus 1200. That's all over 10. So that equals t is equal to 37 plus or minus the square root of 169 all over 10, which is time is equal to, that's redundant, t is equal to 37 plus or minus 13 over 10. So time is equal to 37 plus 13, and it's equal to 37 minus 13. So t is equal to, here we got 50 over 10, and here we have 24 over 10. So time is equal to 5 seconds, and time is equal to 2.4 seconds. All right, but the question says when the rocket first reaches a height. So if you look at where I sketched it, two positive real-time values just mean that somewhere here the rocket hits 80 meters and keeps going, and then on its way back down it goes back to 80 meters, right? That's what's happened here. So when it first reaches 80 meters, that's the earlier time. All right, so let's look at part B. It says, how long does it take for the rocket to land back on the ground? So at ground, h of t would be equal to 0, right? Ground level, 0 meters. So we can just set 0 to be equal to negative 5t squared plus 37t plus 20. And if you want, you can bring everything over to the other side of the equation to change the sign in front as well, but it doesn't really matter. So here we have time is equal to, t is equal to negative b plus or minus the square root of b squared minus 4ac. It's not a very good square root. There you go, all over 2a. Okay, and then you'll work out what's under that square root on your calculator. So I'm going to jump right to that is 1769. And that's all over -10. So that gives us t is equal to -37 plus or minus 42.1. Just like that. So that gives us t is equal to -37 plus 42.1 all over -10 and -37 minus 42.1 all over -10 for a t of -0.51 seconds, and time is equal to 7.9 seconds. So again, think about what we're modeling physically. We just solved for time, so we're going to reject this one here because can't have negative time. Can't have negative time. So at 7.9 seconds, the rocket has landed back on the ground. Okay, so here you've seen in both of these problems, or both of these parts, A and B, you do need to consider what it is you're actually solving for and what it means, what these values actually mean. And that's a trend that you'll see in the rest of these problems. And it's why there's a page of notes that has that written on it as well. Really think about what the problem is modeling.